Well, good afternoon, everybody. Thank you for attending our next presentation in our conception to completion scanning series. This is, I think, number 4, focused on building construction scanning. Our presenter today is Robert Beck. He is our business development manager for our buildingpoint part of our business that focuses on vertical construction. He's going to talk about some of those applications today. And remember, we're going to have one more webinar coming up, and I'll repeat this at the end, December 20th, and we're going to kind of wrap all of our different examples together, and that will be mobile scanning, aerial scanning, terrestrial, and then building vertical structure. Again, a couple of housekeeping items that I just want to remind everybody about. This webinar is recorded, so if you find it enlightening and would like to get a copy of it, please let us know, and we will we'll forward it on to your colleagues, and so that you can do, or send it to you so you can forward it on to your colleagues. As well, the chat will be open, so if you have any questions while we go, we'll try to answer those at the end. Type them into the chat window, and we'll go ahead and answer those when we're done. So with that, I'm going to go ahead and turn it over to Robert. And just so you know, Robert, I can see your screen. We're right now on the brief bio. So with that, just want to give you a heads up that we can see your screen just fine. Go ahead, Robert.
Perfect. Thank you, sir. Appreciate it. All righty, everybody. Well, welcome to Wednesday. Yeah. So this is using 3D laser scanning in vertical construction environments. Just a little brief bio about me. As Steve mentioned, I'm part of the Frontier Precision organization in the division buildingpoint America West. I've been involved in some type of construction technology for well over 25 years. And really my passion in life, with the exception of my family, of course, is to incorporate technology and bring the construction industry into a better way of providing better accuracy, productivity, and of course, overall productivity into the workplace. So a little bit about buildingpoint America West. Who are we? We are a Frontier Precision company. I just wanted to make sure that that's not being seen there. And we provide sales, service, and when I talk about service, it's equipment service. So really anything in the construction technology that has an on-off button, we can help service that. We do scanning services. So any type of project that you have that needs laser scanning, we can do a service on that as well. VDC modeling services, training, and of course, decades and decades of experience. So the purpose of today, we're going to discuss 3D laser scanning for collecting accurate as-built data for drawings and BIM models for renovation, QA, QC. So in the field, being able to validate what we've constructed and make sure it's accurate. And then, of course, using that 3D laser scanning to collaborate with the other stakeholders. So question. Right, so if you look at my picture here and you see an MEP room with a whole bunch of piping and a whole lot of pumps, you know, the question would be, how long would that take you to traditionally measure and as-built that? You know, you're typically using ladders, you're using measuring tapes, scaffolding, lifts, whatnot. So to help answer that, right, it would be days, if not upon weeks, to measure that type of environment. That's why we have laser scanners now. We can go in and as-built a room like that in a matter of hours, and then have a complete data set that we can measure from any point to any point within that room. So here's a little bit of an example of a project that we did a laser scanning job on, actually just last week. So this was a power plant with elevated piping, and you know, their traditional method, once again, with ladder scaffolding and measuring tapes, would have produced an unsafe environment. So we were able to come in here, laser scan it, and then pull measurements for all the pipe fittings that they need to replace in there. So you can see in this kind of graphic here, what I'm doing is pulling from flange to flange and getting detailed measurements. So now they can reproduce the piping to replace bad sections. In another example, we've gone in here and we've scanned an existing building that they're going to be doing some retrofits to. And within scan the whole thing, I think this one took us a little over a day. It was about, and this is just a small subsection of it. It was about 110 scans, so it took us a full day. But what we were able to do is reproduce and create a model. So you'll see on the right-hand side, we produced a Revit model for the client. The client then now has a Revit model to be able to do new drawings from. Some of the other great use cases are scan to BIM field overlays. This is relatively new within about the past year, where we can actually take, if you'll see in the lower right-hand side, you'll see a PDF. So we're able to scan against a scaled PDF. So what we've done is we've gone in and geo-referenced the scanner, scanned against it, and now we can see, with detailed measurements, in this case, this was a hospital, where the exam rooms are going to be, where the doors are going to hit, any type of stub up. So you'll see see on the lower right-hand side here, you'll see a stub up that's in place, and make sure that that's within the walls for any type of drainage for sewer or septic. Upper left-hand corner, we've got scans, and we actually have a 3D model that we've scanned against. So now we can look for visual clashes. Another example in the same kind of arena, we see a lot of scanning being done in the reuse work, which I think we'll see a lot more of as we adapt office buildings to different uses. But going in, scanning the old facility, dropping in the BIM model overlaid, and being able to look for clashes and potential construction issues. Floor analysis. This has become a really big area. Being able to get in and check out the finished floor and the floor levelness before you actually get on the concrete. So their traditional method, let's talk about that just briefly here, for measuring your FF and FL numbers, or you're using your profilograph and you're looking for standard deviation, both horizontally, vertically, or longitudinally and transversely across a given area to make sure that it's meeting whatever FF and FL specs that you have. This traditional method sometimes takes hours, if not days, to go in and verify. With a laser scanner, we can go in, set the scanner up in a safe place off of the work site, scan it. Scanning will typically take anywhere from 3 to 5 minutes based upon the density of the point cloud that you're scanning for. So we'll be able to scan that in less than 5 minutes, bring that data into the field software. Right there in the field, you can run an FF and FL number, which we'll do here in just a moment in a live exercise. Some examples of that. Right, being able to run contours in the field or produce that FL report. So I'm gonna hit escape here real quick, jump into Field Link. Let me move some stuff around on my screen here real quick. But here I've got a sample point cloud that we went out and scanned. It's part of a much larger project. So if I turn on, what I did is just created a clipping plane. So you'll see that this was, once again, I think it was about 120,000 square feet of various areas that needed to be scanned and verified. So created a clipping plane, just a section box in that particular area that we wanted to check. So I'm going to go into my scan software here, hit floor analysis. And first thing is we want to define the floor area, and this is easily done by just picking on the scan, and what it'll do is it'll trim out everything vertically above that floor area, so you automatically have a floor area. So I'm going to pick the floor area here. And I kind of done some test ones here. I'm going to just clear those out real quick because I forgot to do that. Pardon. I previously run this. But now to run it, what I'm going to do is I just want to hit my plus button, drag a line that's got over a minimum of 11 feet. In this case, I'll just pull it and make it 21 feet. Hit accept, and it now creates it. Same thing to get good accurate numbers, we're going to make you do it at least 5 times. So you can see as I'm pulling it, I'm getting my FF and FL numbers below. I'll pull another one down here. Nope. And we'll do a vertical one as well. So once I have a minimum of 5 lines, I'll get a preview button here. And then I can define my SOVs and my MLVs. So I can plug in my values here of 22 and 18. So based upon the specs of the project, just plug those in. Hit preview, and you get a handy dandy floor flatness report with graphics and everything. So this will tell you it'll show you what your SOVs were and your MLVs. And then as you scroll down, it'll tell you whether you passed or failed accordingly. And once again, all this was done in really less than 10 minutes. We were able to set up the scanner, have it pre-register, scan, transfer the data, define the area, and then run this report just as we did in really less than 10 minutes. So we can save the report. Once we do that, it'll save it. We can email it directly from the tablet off to all interested parties. We can also create a contour map. So here, what I've pre-done is I created a contour map just in the sake of time by clicking on what our elevation needs to be. The software will run through and create a high-low contour map. So we'll see the areas of high, the areas, so in this case, we're high. And this was actually a piece of plywood that was on the ground, so you can see that we picked that up. That's how accurate it is. Once we do that and we run the report, if I was connected to an instrument, we would actually have an aim button down here as well. And what we'll talk here in just a few minutes about is the scanner actually has a laser pointer built into it. So we can take that scanner, turn on the laser pointer, and then aim to these points that were generated along the low and high lines. And it'll show us directly on the ground now with the pointing laser that we can go mark out and delineate those areas that either need to be milled or filled. So super functional in the field reporting here. And of course, there, as I was talking about, there's your little layout button. So if you have any questions, please start typing those into the chat window, and we're going to make sure that we address those here at the end of the presentation.
Hey, Robert.
Yeah.
There is one on-topic question, but I think he came back and said you answered it. But the question was more along the lines of exporting this floor flatness report with Trimble Connect. I'm not sure if that's something you can answer right now, or if we want to kind of hold off on that one on the end, but it definitely was related to what you were showing.
Yeah, so the report itself, when you click the report button, this will generate a PDF report just like we did with the floor flatness as well. So here I've got the contour map report, but I also have the floor flatness report. And if I'm connected to Trimble Connect, so there's my Trimble Connect, everything gets saved into the My Documents Trimble Field Link Reports folder, and then that will be automatically synced up to Trimble Connect. So everybody who's on that environment has access to it. So
Okay,
great
thank you.
question, keep them coming. I do like questions. Just hearing my own voice. So yeah, so here's the example, once again, kind of the floor flatness report that you get out of it. Very user-friendly, very easy to read. Next, we'll talk a little bit about inspection. So inspections, once again, are built directly into the field software that we can scan against a BIM model. And I'll talk a little bit that here just a ways down about how we actually geo-reference the scanner to it. But in this case, what we're doing is we're scanning against a BIM model and then letting the software analyze the point cloud that it collects to that model and then generate, for lack of better terms, a heat map that shows us areas of deviations. I'm going to jump in here once again, change projects. Let's just take just hopefully a brief second here. Yep. And so as before, this is out of a much larger scan area. Just did that for the sake of time, so everybody at home doesn't have to sit there and watch the wheel spin around a little bit. But this is a scan file that we previously scanned a model. And so if I turn upside down, you can see the caissons and everything around there. So there's your model. So I'm going to go back into the scan module, run an inspection report. And if I go in there and I type it, footings inspection, and I'm not speeding this up at all, so you can actually see how quick it is to do in the field. And now we have an inspection report. So I can adjust on the left-hand side, you'll see my scale bar that shows me what my values are for the color-coded areas. I could either hit my decrements either up or down to increase or decrease those. In this case, I'm going to go down to 1/4 inch. And you'll see that my legend on the left-hand side is changing. And then my actually inspection data is changing as well. Move this around a little bit here so we can see, and I'll zoom into some areas. And once again, if we see this kind of darker green area, those are areas that we want to look at, definitely up to red. Now, some of this is where there's dirt involved and whatnot on top of it. So some of it we might just kind of look and bypass. But we're against some of the walls, we definitely want to look at and inspect visually here. And so we can see that according to where the BIM model, where we're supposed to be and where we actually scan to, we see deviations. So certain areas are spot on, certain areas are not. So this gives us that validation directly in the field as the work is being done, so we don't have to catch it days or weeks down the road. And so we can visually just come through the whole project, check it out, and check for problems or issues, both horizontally and or vertically. So you can see here on the top, we're pretty much so on where we need to be here. This area, we're a little bit low. Same thing here. And being a 3D model, scan data, you can zoom in and look at it directly. If you're having a hard time seeing it, you can increase your point size value as well. So we'll see that's a little low right there. I'm going to minimize fielding. Come on back into our presentation here a little bit. Oops. So with that, right, so it allows the user to accurately verify in the field against our model. We've kind of made it look quick and simple here in the live demo we just did, but it really is that quick and simple. So I didn't have to struggle to make it look simple. We've actually gone out, worked with clients in the field as we're going through the process of onboarding them. And most of our clients have said they're seeing anywhere from 400% to 1100% return on investment for the scanner solution. A lot of that comes down to is catching the problems before the concrete's poured, and you don't have to jackhammer out, remove, the issues and do rework. That's really where a lot of that comes down to. One of the projects we recently went out to, the customer said on a 20 plus or minus story building with decks being poured on a weekly basis, the system paid for itself in 4 decks, being able to find problem areas before they were really a problem. So now we're going to talk about some of the key deliverables that we can get out of the system. In-field georeferencing. In my mind, there's really, with the solutions that we have now, there's really 2 key things that help with the workflow, and that's georeferencing, and that's the scanning registration, all being able to be done into the field. I've been scanning for, probably about 15 years now. And I will say the old way of scanning, being able or having to put up spheres, checkerboard targets, scan against those, and hopefully you got everything right, and then bring that scan data back into the office and start your registration process was time consuming and extremely frustrating when you couldn't get it to register correctly because you've left the field, you have to look at scan 1, scan 2, and if you have 100 something scans, trying to get all those pieces back into the line, very, very time consuming, and as I said, frustrating. So now being able to actually do that directly in the field, so as you're there seeing the problems and fix them directly on the tablet in the field is just a huge time saver. So here's a little bit of an example where we set up targets. So you can see in this kind of little shaded green area here, this is actually a prism pole with a black and white checker on top, and I made a little bit of a larger, oops, I didn't want to go there yet. Black and white checker on top, set up over a control point. So using the laser scanner, as we stated before, it has a pointing laser on it that we're able to steer, and I'll show you a clip of that here in a minute, steer to the target itself, capture that control point, and we can capture up to about 5 control points and that are aligned within the model. So when we start scanning, everything's automatically going to be aligned. So here's an example of that, and we'll just kind of watch the video here. So we have the scanner set up. My buddy Steve walking over to one of the control points with the paddle board. And you'll see the little laser. And we're actually steering it directly from the tablet. So this is what's called dynamic joystick. Clicking it on there, slightly moving the laser to align to it. So we're going to capture that. It's going to hit the little measure button right there. So it's measuring. I'm going to move forward here a little bit. That's the beauty of the video. Now we can go in there and we can find our second control point or create a control point directly within the software, which is called Trimble Field Link. We can go in, and as long as we have an intersection, midpoint of lines, we can physically create new points. But in this case, we had pre-established our control points, so we're going to use the same process. Turn on the laser. You'll see the laser being there, and just using the slider buttons, dynamic joystick, or what we call the little nudge buttons here, being able to nudge that laser left or right to get it to where we want it. Hit the measure button. It usually takes about 8 seconds to measure. Once we do that, we're going to see it's set up. So I'm just going to slide forward here a little bit, and we'll see now it shows us where our control points, if you're looking at the lower left-hand screen, where our control points are, where the instrument is, and what was probably really hard to see on the screen is what the residuals were. And we display those in layman's language like poor, good, very good, or excellent. In this case, it was excellent. So now as we start scanning, the scan data is going to be aligned to the model, to the physical world. And we start scanning, and you'll see it all pop in. So that's really how simple it is to set up the scanner, geo-reference it to your project, and get the scan data to directly overlay. So I'm going to just move forward. After you're done with the setup and the scanning process, you're actually going to get an in-field registration and refinement report. This is going to show you your average error. So in this case, we had 2.2 millimeters of error, which I think is pretty good. Number of stations we set up, average overlap of the scans. In this case, it was about 54% overlap, and what the confidence level is for those scans to overlay each other and make sure they're in the right position. And then, of course, we can share the data, right? It's not any fun to actually keep everything to ourselves. So we have a lot of different methodologies for sharing that data. If you're in the Trimble, as I call it, ecosystem, if you're using RealWorks or SketchUp or Siskiyou or Connect or Cloud Engine or Business Center, Trimble has made it so most all of their scanners will directly export out a TDX file. And so any of these softwares will be able to import that, and then we can bring that data directly into those platforms. And of course, we can export it out to most any other package that can accept scan data and that are designed for it. So most all of your Autodesk products, AutoCAD, Navisworks, Revit, of course, and Inventor. We've seen a lot more people using Inventor for object modeling. So we're able to export that and bring that into there as well. You'll see here that there's 2 different types of data, structured and unstructured or non-structured. What structured is it actually keeps the scan station locations as part of that data set. Non-structured is it's just going to loop it together and say I have one giant point cloud of registered point cloud data. Most people want to end up typically go with the structured, so you maintain that station setup. Some of the newer sharing platforms we have. This is an example of Trimble Cloud Engine, which is super powerful. That is pretty much so. Well, there's a desktop version and a web version, but we can overlay, and you'll see. I mean, this is actual scan data, so you see the clarity of it. With BIM models that are overlaid. So we can put in information, we can put in notes, we can put in measurements, tag anything that we need to tag, and then push that to the cloud. So whoever's on the other side, on the review package side, can see that information live, just as we're doing it as well. Here's an example of a BIM model that was brought into Trimble Cloud Engine, scanned against, and then imported that information in. With this type of kind of workflow, we can decimate, or AKA bring down, the amount of density of point clouds, because not everybody needs to have millions and millions of points that define a wall or certain areas. So we can actually use these tool sets to decimate that data and make it more consumable on the other end, so you're not dealing with gigs and gigs of data, as we typically are with scanning. So with that, I kind of flew through that at a record pace, I believe. We'll open up to questions and answers.
There are a few questions here, Robert, thank you. The first one is, how many scans to perform a mechanical room? And I think maybe to add on to that, with your experience on doing mechanical rooms, how do you approach a mechanical room? Because it's got a lot of stuff going on.
It's got a lot of stuff going on, yeah. So yeah, I've done more mechanical rooms than I ever wanted to do. With that being said, it really depends on the size and how dense it is. The trick to scanning is to be able to walk into a room, and whatever you see is what the scanner is going to see. So if you can't see it physically from where you're standing, the scanner won't be able to either. So you're going to have to do quite a few setups to capture what it is you're trying to capture. So it's not an easy answer, but to give an example of a dense mechanical room that's maybe 30 by 30, I might end up doing 25 to 30 scans in that area. Now, I would not do them on any standard or high resolution settings. The scanner, you have 3 settings. You have a low, a standard, and a high. And what that does, let me give a kind of a back overview with the scanner, is the scanner is always collecting 500,000 points a second. As we increase in our density of scanning from a low to a standard to a high, all we're doing is slowing the scanner down, so it's collecting more dense data at a distance. And so with that being said, if I'm close to the objects, I don't need to slow it down because I'm going to get a lot of information that's close to it. So in a mechanical room, I will typically only do a low scan. And if I'm doing 30 of them, they're usually about 2.5 minutes with color. So it's actually capturing the photos. But I'm doing 2.5 minute scans. And if I'm doing 30 of them, then you can see, I'm probably going to be there for a little over an hour to 2.
Thank you.
Did that help answer that question?
I think you covered it pretty good. I mean, not every mechanical room is the same. I think you gave a good idea.
Yep.
I think the next question was related to just the difference between FieldLink and RealWorks. There may be people on here that are just not familiar with what FieldLink is, and maybe you could just describe that.
Yeah, so FieldLink is a software that's specifically designed for the building contractors. So super powerful, but yet very user friendly. As you can kind of see here, let me just jump into it. You can see the user interface. So the user interface is designed for contractors, speaks contractor language. If we want to go measure anything or scan, right, I would just go into the scan. And if I'm connected to the instrument, I just hit collect. And once I hit the collect button, that's when I'm going to get those settings of, do I want a low, medium, or standard, or a high density point cloud? And I literally just hit the start button and start scanning. So super simple. But with that, there's not a lot of analytics. We built in, as we showed, some of the floor analysis and some of the inspection reports. But there's a lot more that you can do with scan data, and that's where RealWorks comes in. So RealWorks is your full-blown scanning software, to where we can actually now start modeling into it. So I can bring that scan data in, and if I have all those pipes and pipes geometries, I can model directly in that package without having to go to AutoCAD or Revit or Siskiyou, for examples, right? There's more analysis tools. If you're doing tanks, we have a tank module that you can go in, scan big water tanks or midstream oil gas tanks and get volumes. So a host of different analytics that's not going to be put not necessarily in the field. Try to keep the field as simple as possible.
Yep. So FieldLink is the actual collection software with some added functionality, and RealWorks is where you process the data, more refine it, and maybe even do some modeling and exporting as well.
Yes. Good summary. Thank you.
Thank you. I have an X7 with perspective. Can I load FieldLink, or can I load and use FieldLink with that X7?
So you should be able to, right? There's different, depending on the generation of the scanner, there's some slight hardware differences. So I don't want to definitively say yes, but more than likely, absolutely, right? So if you've got a tablet, we can most likely get FieldLink to run on that as well.
Okay. What are the parameters for the FF/FL lines? The previous parameters were at 45 degrees and quite limiting. So I think you were drawing lines on there to define your floor.
Yes.
I think that's the question. What are the parameters? I do believe you said 11 feet minimum, but are there any other parameters?
Yeah, so parameters, so you have to have a minimum 11 feet. You can cross. I think some of what you were talking about is there's diagonal areas. We only allowed, because I think if I remember right, and somebody can fact check me on this, but per ASTM 1155 standards, they are horizontal or vertical lines. So that's what we hold it to.
Okay. Do you suggest a program to help this data to be adjusted easier? And you've referred to RealWorks a little bit. Do you want to elaborate on that based on the question?
Yeah, so as far as the adjustment, my guess, well, it could be two parts there that we're talking about. The registration of the data. So that is, I've got scan 1, I've got scan 2, I've got scan 3, and I want to bring those together to make one point cloud. We're directly going to do that in the field within FieldLink. However, you could get some minor shifts in it, or there could be areas where you just in the field, there's not enough overlapping or coincidence of points to be able for it to fit. So that's where RealWorks comes in. Being able to take that data back into the office in RealWorks and use cloud-to-cloud comparisons, using different targets, using 3 points to be able to create in the different scan areas and connect those, and then have RealWorks register that data. So that's from a registration standpoint. That's where RealWorks would come in. So yeah, we've got multiple tools to help with that process.
Okay, thank you. One more popped in here. What's the best overlap distance to use as a baseline?
That depends on what you're trying to scan once again, right? The way that the registration process works nowadays, right? So as I said, years past, we had checkerboard targets, we had spheres. Now we use plane. So we use a plane-based registration. So what it's going to do is it's going to look at the geometries of walls, doors, floors, ceilings, and it's going to use those planar surfaces to look at from scan 1 to scan 2 to scan 3 and say, oh, I see that geometry in these 3 scans, therefore they must fit. And typically we want at least 30% overlap to get the best geometry fit. So hopefully that helped.
Cool. I appreciate it, Robert. I don't see any more. Those are great questions, by the way. Thank you, everybody. With that, I do want to thank everybody for attending today's session. Look for an announcement and a registration link coming out soon for our last webinar. That is going to be kind of wrapping this all up together into a bow and discussing the 4 different applications that we did in this series. That is going to be December 20th, Tuesday, December 20th. With that, again, I thank you, Robert, for the presentation today. It was great. I learned a few things myself, so that's good. And hopefully everybody else got something out of it. So Again, look for the recording if you're looking for that. That should be available within the next 24 hours or so. It'll be posted on our YouTube channel under Frontier Precision and Building Point America West, both. And with that, I'll let you guys all go. Thank you.
Yeah, well, and just real quick, Steve, so if anybody has any questions in the meantime, go to our sales at buildingpointamericawest.com. It's on our page, and if you have any questions in the meantime, that comes right into Steve and I, and we'll be able to answer those questions too.
Excellent. Thank you, Robert. Thank you all. Have a good day.
Thank you.